The broadcast is now starting. All attendees are in listen-only mode.
See, that's what I was saying before. It wasn't talking out of here. It was talking out of there.
Oh, where'd the cable go?
That one. Here. Does it show it now? Look over
Which
here.
device did you plug in? So speakers, external speakers, medium. I have to say that. Yeah, that's fine.
Okay. And then here. No. It's
I
weird.
don't know if it'll catch it that quickly.
So I just don't know, like, if
Well, it'll
video,
still.
if, like, there's actual video on here that has sound.
It does not. No, he doesn't care about the sound.
But next person.
Well,
I'll have to fix it before.
But again, that won't matter for the audience here.
Yeah,
Because
because
that
it's
comes.
not.
No, that comes through the HDMI.
Are you sure it's
Yes.
still going to do it?
Yeah.
Okay, then.
This is just on GoToWebinar that's being weird, but that shouldn't impact.
Okay. So we have the screen we're going to show. Is, but this, would you just have it in regular presentation mode or?
Yeah.
There we go.
Oh, that's Julie. What's your name?
Show screen. Which screen are we going to show?
Are we under control?
Almost.
Yes.
Right, okay.
She's just finishing the broadcast, but then I think could probably start
Right.
introducing.
Okay,
Is
well,
this
I will
plugged in?
introduce
Yeah.
Terry.
Wonderful. Do watch your step if you come back here at all, because it's a little.
I will, right.
Yes.
Yes, that's fine.
Can you set it the first one?
Okay, so welcome back to this afternoon's session. Welcome to this afternoon's session.
Sorry.
Sorry, I'm in the way. I'll stand over here. So this afternoon's keynote
the red and then forward
is
and backward. Just watch your step here.
by Professor Terry Callaghan. Terry I've known for, can't work it out. I'm going to say 15 years. That sounds about right to me. It might be 20. Terry is an ecologist. Terry wears very many hats, but he's an ecologist. He divides his time between the University of Sheffield and the University of Tomsk in Russia, which is an interesting story in itself. What he's going to talk to us about is something which has been on our minds throughout the workshops we've had, which is how effectively to make collaboration work between countries. And specifically, Terry's going to talk to us about the Interact programme. I've been a grateful beneficiary of the Interact programme for about 5 years now. It's been one of the things that's really helped me to carry out the interdisciplinary and international research work that I do based in Russia. So, as I say, the Interact program helped me a great deal to make that happen. So, Terry, if I can hand over to you, tell us about the Interact experience.
Thank you very much, Gareth. Good afternoon, everyone. I've been involved in the Arctic for 52 years. So I started my work in the Arctic well before there's any indication of climate warming. But at heart, I'm still an early career scientist, so I'm still doing new things. And out of those 52 years, I think I've only missed 2 years of fieldwork in the Arctic. Since before Christmas, I've been in Siberia 3 times, and I will be back in Siberia in 2 weeks' time. The talk is not in isolation. There are a huge number of people behind me. I'm the tip of the iceberg. But in particular, I'd like to acknowledge Margareta Johansson from Lund University in Sweden. She started as my assistant and PhD student, and now she's my boss. And she is the coordinator of Interact now. But also I'd like to acknowledge Olga Morozova from Tomsk State University in Russia, who makes visits from foreign scientists to that part of Siberia work, and she has also helped to make the educational resources that I'll describe later work. The first part of the talk is not for children, it's not for school students. It's to make a point, and that point is that the worst case scenario of climate change we don't talk about. It's politically incorrect to mention, but the worst case scenarios are about geopolitical conflict and mass migration. And if we look at what is happening in the Arctic, despite having the Arctic Council of Ministers and the good work they do, we still have a lot of geopolitical tensions. Canada has built a huge research station on the Northwest Passage simply because the US hasn't acknowledged that that is territorial waters. The Russian Federation is closing down the New Siberian Islands, where I did a lot of work in the 1990s, because it's become a military base now. The US is putting Marines back onto the border between Norway and Russia near the Murmansk area, and also back in Iceland, and several countries are claiming the North Pole since a friend of mine actually put a flag, a Russian flag, under the North Pole on the seabed in 2007. So there are a lot of tensions, and we know already, this is already, and we know that soon there will be major impacts of sea level rise. So there is a prediction that over 100 million people will be affected by sea level rise. In addition to that, there are people who will be affected by lack of water, desertification. So in the future, sadly, there will be millions of people on the move, climate migrants. Already in Europe, we cannot handle tens of thousands of immigrants from Syria and from North Africa and from the African mainland. We can't handle that degree of human movement. How are we going to plan in the future? And if we don't talk about it, we're not going to be able to plan for it, and we're going to have disasters. So we need plans for the future. We need collaboration. We need to break down boundaries between countries. The Arctic Science Cooperation Agreement is a top-down science diplomatic exercise to break down many of these boundaries. But this is very much top-down. This is ministers and senior Arctic officials working together to break these barriers, not the scientists who work in the field. So Interact, we think, is a place where the top-down and the bottom-up science diplomacy meet. We are a network of 86 research stations. I'll come back to some of the statistics later. But what we do is we put researchers together with decision makers, together with indigenous peoples, and together with educators. That's why I'm here, to try to solve some of the problems or prevent some of the problems of the future. And although we are a bottom-up organisation, just researchers, we do work with embassies, local government, local peoples, and we help adaptation to climate change. A little bit about this bottom-up organisation. The power we have, we're unlike other networks because we consist mainly of research station managers. We have 86 research stations in 18 countries, and each year these research stations together host about 5,000 scientists. So most I would argue that, and with Gareth's approval, until remote sensing came on the scene, where anyone can access the Arctic, until remote sensing, most of what we knew about the Arctic came from these research stations, because they are the fabric that allows researchers to live and work in the Arctic. So we have 86 of them, 5,000 visitors per year, and we span all the Arctic environments. The graph on the right expresses Arctic environments as a very simple climate envelope, with temperature on the vertical axis, with the coldest at the top, and on the bottom axis is rainfall or precipitation. And you see that we span all the different climate zones, from the very cold deserts to the wetlands of the Faroe Islands, the wet pastures there, the boreal forest, and there's one spot in the middle of the Greenland ice sheet. The curve there is the mean equilibrium line on glaciers. So everything above that line is glaciated, everything below is not. And you can see our spread of stations. We are present in every Arctic country and all the countries bordering the Arctic, and we have very big presence in some countries like Russia. We were the people who opened Russian research stations to Western scientists and Western research stations to Russian scientists. Not only do we have these 5,000 visitors, but we are the fabric that makes networks work. So in the middle of that ring, you can see the map of the Arctic and our research stations. Round the edge, you see 156 rings. Each of these rings is a network. And those networks are operated or made possible by research stations in our Interact network. And we've just given a few examples. There are some very big global networks like World Meteorological Organization. There are EU consortia that we support like LifeWatch, long-term ecological research, and an experimental one, ANEE. But we also support educational networks like UArctic, and hopefully in the future, maybe polar educators too. So we have to talk about that. But I think you can see that without the bricks and mortars and the energy and the transport of some platform on which to work in the Arctic, a lot of Arctic research would simply not be done. It would be impossible. We produce a lot of information for potential visitors to the research stations, whether they're kings, queens, ambassadors, prime ministers, just scientists, PhD students, and so on. And these materials are freely available. We have an Interact Station catalogue, which is, if you like, a researcher's guide travel brochure to the Arctic. So you can flick these pages over and you can see where you would like to go. If you want to find permafrost or glaciers, then go through these pages and find out where it occurs and what station you can go to study it. It's also available with the help of APEX, the Association of Early Polar Career Scientists, and we work with APEX in very many different ways. We also try to think laterally and try to think of how we can engage people. So instead of having, even though it's very nicely illustrated, instead of having this book as in hard copy and PDF, we also have a game. We have trump cards. So if you want to have a look at these later, you can have a game, and on each card is a research station. So you see a particular research station, whatever it is. Here on the screen, you've got the Arctic Research Station in Disco Island, West Greenland. And on the back of the card, you've got all the statistics about that research station. Here you can see some on the screen. How far is it away from population centre? How high is it? How cold is it? And with these statistics, you play games and learn about the environment in the Arctic. We have something very special, and I can't promise it for teachers, unfortunately, at the moment, but I can promise it for early career scientists and senior professors like Gareth. This is Transnational Access. This is a scheme where we have money from the EU to put scientists into the field. The problem is we cannot put, or the advantage is we cannot put a scientist into the field if they have an infrastructure in their own country. So we cannot fund a Swede to go to the Swedish research station in the subarctic at Abisko. But we can fund that Swedish researcher to go to any research station in Russia, in Greenland, in Faroe Islands, Norway, Sweden, Alaska, Canada. So this is transnational access. You go to another country, and when you're there, you meet other people from that country and from other countries as well. You cement collaborations, and new research grows. This graphic shows where we are at the moment. The thickness of the line shows numbers of research groups. Every single line is a research group. The flags are the destination for the research. The dots are where the research is originated. And you can see that most of the researchers are coming out of Europe because it's a European grant mainly, but that those people from Europe are going all over the Arctic to Canada, Alaska, Siberia, Greenland. We have another type of access which could be very useful to teachers. This is called remote access. So it's good to go to one research station somewhere in the Arctic to do your research. What happens if you want to visit all 86 research stations in the Arctic in a summer? Of course, it's impossible. But what you can do, you can seek funding from us to ask the station managers and their technicians to make an observation, take a photo for you, collect a sample, and then do your research for you so you can blast a whole number of different research stations. So this is an innovation, and it also, incidentally, reduces the footprint of researchers in the Arctic. Because we have to remember that, like the Antarctic, if you go to the Arctic, the high Arctic, where there are no indigenous populations, the greatest impact on the environment is through us, the researchers. So we need somehow to reduce our footprints. We are committed to educate. I started my slide by being shocking, and that was deliberate. I wanted to impress on you the seriousness of what faces us. But the people have to solve these problems. They're not us. It's the next generation. And what we should be doing is empowering them with knowledge of what is happening and how to prevent it. So we are heavily engaged in outreach and education in various forms, all the way from the public and decision makers, all the way to primary school children. And I should say at this point, with the primary school children, we're working with Wicked Weather Watch, and Vicky and Jill are in the audience. They will be talking to you later. And the older age classes are handled by Agata Godzik from Poland, and she will also be leading a session. So Interact works with these different groups. This is one of our first pieces of outreach. It's we heard yesterday about stories, and we call this Stories of Arctic Science. We call it stories because the indigenous peoples taught their children and their grandchildren about the Arctic and the way of life, not by showing them graphs and histograms, but by telling them stories. So we told science stories. There are 152 authors, I think about 55 science stories. Each story is 2 pages, and you see it here. This is one story. And incidentally, this has got a very, very wide circulation. It's gone to prime ministers and royalty, and I even saw it on a poster downstairs, the graphic of the bio-albedo. So this was published in 2015, but it's still topical. So these stories basically have a standard format. What did we do? Why did we do it? What did we find? Why is it important? And it ends with what was the adventure? Because we're trying to hook the next generation to get out into the Arctic and to do the sorts of things we've been privileged to do. That is, for all of you who are interested, that's a PDF on our website, freely available. We do other things as well. We have a system called work packages, which are the building blocks of EU consortia, and we have many different building blocks. I've just picked up one here because I think this is quite relevant, and particularly relevant to what we heard this morning about the plastics. We know that there are a lot of problems going on in the north. We know there are a lot of potential problems going on in the north. For the first time in history, we have 86 research stations all over the Arctic, and with one email, with pressing one button, we can alert all those station managers to make an observation or collect a sample should something bad happen, like the release of a radionuclide, the spread of a disease, invasive species, or whatever. And we are now at that level where we can help the world solve large-scale global societal challenges. And now we have a structure for alerting station managers, for putting them in touch with the experts who know what to sample, what to look for, and then the analytical labs who will make the measurements. And then the big block at the moment is what do we do with the data? Because we know that some countries will not allow us to publish the data. That happened from Chernobyl. My institute at that time made a map of the radionuclide fallout over the whole of the British Isles within 3 days of Chernobyl, because we sat on the equipment that could do that, mass spectrometers and so on. My boss at the time, he published this in the Sunday Times, I think it was, and he almost got sacked. He got into very, very severe trouble because the public knew about what was happening before the government. So we know that there are some problems we have to face in what we do with the data when we have it. But we have the system to make observations throughout the Arctic in response to a single entry point. I'm going to boast now, so please forgive me, but as a result of Interact, we have stimulated the formation of national networks. So we have research stations that didn't previously talk together, now networking. We have a new network in Sweden. We have other networks in other countries. The big one I want to tell you about is the one that I'm most involved in because I helped to co-found it, and that's the Siberian Environmental Network. And I've been talking to some of you in the audience about the beauty of going to Siberia, the need for Siberia. I'm not Russian, I'm English, but I think I'm the only person actually representing Russia here. And when you look at this map, Russia is 2/3 of the Arctic landmass. So we can't understand what happens to planet Earth or influence behavior unless we engage Russia. So here is the Russian Environmental Change Network. And what most of you don't know, it follows, the original part of it follows the River Ob. Can I be clever and use this? Yeah. And the River Ob comes out into an estuary here. This is the Yamal Peninsula. And it winds its way from the Altai Mountains down here. And we start in this area with environments like this. It's a desert. Who knew there was a desert in Siberia? Okay, this is a bit of the Gobi Desert that goes across the border from Mongolia. And then we go into the high Altai Mountains with snow leopards, then into the Central Asian steppes with camels, then into the taiga, and then finally beyond the tree line into the tundra, and eventually into the high Arctic here at Belia Island with the polar bears. So this is a massive environmental gradient, and we can learn a lot from that, from research in that area, and we can learn a lot if we bring the Russians on board, and that's what I'm dedicating the remainder of my career to do. We need educators such as most of the people in this room. We also need science communicators. Why? Well, I was very privileged to be involved in the very first IPCC nearly 30 years ago, and I was involved in several IPCC assessments after that, and also in the Arctic Climate Impact Assessment. Many of us think that that should have had the Nobel Prize in 2007 rather than IPCC. But look what we said. IPCC warned in 1919, as here again in 2005, of changes in the amount of precipitation, significantly altered hydrological regime, that means intense rainfall, sea level rise, increased variability, extreme events. We said that 30 years ago, and no one's listened. So the photos at the bottom are what you see today, with flooding in Florida and massive storm damage all around the world. But this was predicted 30 years ago. And what we have seen in the last 30 years is increased evidence, slightly refined models, but the big picture hasn't changed. But no one prepared for it, no one planned for it. So if I return to my first shocking slides of human migration and sea level rise, then we have to plan, because if we don't, this is what's going to happen. We can't just say it. Okay, this is an academic saying this will happen in the future. Let's brush it aside and just continue as normal. We can't do that. Otherwise, planet Earth will be in a terrible mess. Okay, so Interact is contributing to outreach. I showed you the Science Stories book. We have a website with lots of resources on. And we're working with Wicked Weather Watch. What we did, one of the things we did with Wicked Weather Watch for school children is produce a series of wicked experiments. An experiment for teachers based on one sheet that Jill and Vicky will explain to you. And the advantage is, this is not high-level technology. What you need is a kitchen roll holder, bit of cardboard, and a wooden spoon from the kitchen, and then everyday articles and burnt match, bits of twigs off a tree. And from that, you can build up a story of environmental change and show how scientists understand what has happened in the past environment. Extremely simple. But these are things that work at primary schools. We come up with some of the ideas, and we respond to Wicked Weather Watch ideas, and then Wicked Weather Watch puts it into operation. The other thing we did with the help of Russia is we produced a mass online outreach course called a Mooch. And this one is a changing Arctic. It was produced wholly in Russia by the Russians, and it was shot in 2 days. But the amount of work that went into it took months and months and months. But this just shows you the impact it has, that there are almost 5,000 learners on the English version, and the same number in Russian, because this is in Russian as well. We present it so that anyone can go in there freely, take resources out of it, or photographs out of it, or a story out of it, whatever they want, for free. If you want a degree, not a degree, but if you want a contribution to your degree, it counts as a formal qualification. And you have that qualification, you've completed the course. And this qualification is acknowledged in the European system and in the University of the Arctic. So this is part of the University of the Arctic. But if you look at the numbers, they're big. So if you add to that, double it with the Russian contributors, it's reaching a very big audience. And now I'm depending on the technology. Another very nice collaboration we have with the Russians is the Russians are extremely good with art, and they're extremely good with computers and computer technology. So we're working with them to produce animations. And we have 4 so far and 2 in the pipeline. And I'm going to try to show you just a few seconds of one. We have 2 animations on permafrost dynamics, 2 on glacier dynamics. And this one is a little bit on glacier dynamics, but hopefully I can get to here, but I'm not doing very well. And this is just a very, very short segment to show you what we can do. So you see it snowing. Now it stops snowing because it's getting warmer. On the left, you have the glacier that is under stable climate. On the right, you have a glacier in climate warming. And you can see the runoff and the moraine formation. And you can see moulins there. And you can see the debris flows on top of the glacier. That's it. That's just one short section of the animation. But what I wanted to impress on you is the power of the animations like this. That within 4 minutes, we can show people what has happened over several thousand years, or what will happen in the future in several hundred years. And we can get that message across visually in 4 minutes. So we're trying to invest quite a lot of time and resources in producing these animations. And we also want to be responsive. Agatha, within her group, has got a questionnaire that goes around school teachers all around the world. Is it 52 countries? Yeah, in EduArctic. 58 countries. So we can ask teachers, and I ask you here now, what you need. Because what we're producing is what we think you need, but you tell us what you need, and we already have one survey, and we're working with that survey to try to fulfill some of these wishes. The next animation that will be released very soon is about the creation of hanging valleys. This is a hanging valley here in the Swedish subarctic, and this is just showing how we do it. We make graphics of different stages of the process. Here's our hanging valley, and then we give it to the animators in Russia, and we give the photos, we give the drawings, and then they come up with the animation like you just saw in the last sequence. The next game, which is I'm going to ask for help for as well, which is an extremely early stage, is a fun game, we hope, for young children, which is based on art and pattern. So if any of you have nice patterns, let us have it, because we will play a memory game based on patterns. So we'll have cards which have patterns on like this, on the left and on the top right, and there are many, many more patterns. And what the school children have to do is match up a pattern with an explanation of what that pattern is. And of course, what we have here is sea ice in front of the glacier, and on top there is polygonal tundra. And this is a game that I already mentioned earlier on. These are very simple and cost-effective games. Now then, I started off with shock tactics. And some of you have seen this slide before, so Jill, Vicky, please forgive me. But when I teach to a lot of people, I give outreach to a lot of people, all the way from prime ministers and government down to primary school kids. And the most difficult question I've ever had was by a 6-year-old child who didn't know what the question was. He didn't know the importance of the question. But the question was, what was the hardest thing I ever had to do in my career? And of course, the children were thinking of meeting polar bears, crossing glaciers, flying in helicopters, all the fun, exciting things we do all the time in the Arctic. I had to think, but the answer was none of the above. The answer was the hardest thing I ever have to do in my career is go to a school of extremely enthusiastic kids, tell them all the problems of climate change, and not be able to tell them the answers. So the pessimism of what we talk about, it's very difficult to get round because we can't promise we're going to fix everything, because we're not. We can take carbon out of the system, but we're not going to put our glaciers back. We're not going to put our ice sheets back or our permafrost back. It's not going to happen. And if species become extinct, we're not going to put them back. But then a German industrialist, I was speaking in the Ruhr Valley to a group of townships there, and he said, do you have any grandkids, Terry? So I said, yes, I have 4 grandkids. He said, what happens? This is one of them. Oh, where is it? This is one of them, Kira. What happens if you promise to take them out on a picnic or something and it rains or it snows? And I said, no problem. We'll just put on appropriate clothing. He said, exactly. So what you're doing is you're adapting her for the future weather. So when you go to schools, when you're talking to the public, what you're doing is you're telling them to put on their outdoor clothing for a different climate in the future. You're adapting to different weather conditions. And the story is the future for the next generation will be different than ours, but it will be good if they're prepared for it. If they're not prepared for it, it'll be a disaster. And our job is to prepare them for it. And Jill and Vicky and I have a friend, a famous explorer, Sir David Hamilton Adams, and he always reckons there's no such thing as bad weather, only inappropriate clothing. And it's the same for our future climate. It's not going to be a bad climate, it's just going to be different, and we have to be prepared for it. And it won't be bad if we're prepared. If we're not prepared, it'll be a disaster. So that's what I wanted to say. This is the website. Interact, you come onto it and explore it. Take as many resources from it as you wish. And if you have requests for new resources or contacts with scientists in the field or contacts with research stations, I think next week I'm doing 2 video messages from Siberia. Please let us know what you would like and we can fix it up. With 86 research station managers all over the Arctic, we can, and 5,000 scientists every year, we can do it. So thank you very much for your attention.
Thank you very much. And there will be a chance in the panel to grill Terry on anything that he's said or interact with Terry again. So we will move on to our breakout sessions. The first thing to say is that session 3 has been relocated to be in here. So I'll once again make a hash of reading out people's names and where they're supposed to go. But before I do that, I'd like to say that the 3, in fact 4 projects that are here are all UK-based but international polar education projects of very high calibre. Found them eventually. So you've probably already met the people involved, but they are the 2 that Terry mentioned. There's the one bringing her up Edu Arctic, right around. There you are. All the way from Poland. And